Half-inch thin breakers will pass inspection if they are listed by a nationally recognized testing laboratory or an RTL, such as Underwriters Laboratories, Oral, or Intertech, or ETL. The thickness of a circuit breaker does not affect its functionality or safety. The size and thickness of a breaker are primarily determined by the current rating and available space in the electrical panel. Thin breakers are designed to fit in smaller electrical panels, allowing for more circuits to be installed in a limited space. They meet the same electrical standards as thicker breakers and provide the same level of protection for electrical systems. When installing thin breakers, it is important to check the compatibility with the electrical panel to ensure they fit and operate properly. Always refer to the manufacturer's instructions for specific installation and safety requirements. Electrical panels and circuit breakers are critical components of electrical systems, designed to protect circuits from overloads and short circuits. Understanding their function, types, and proper installation is essential for ensuring electrical safety in buildings and homes. Let's delve into the details of electrical panels and circuit breakers, discussing their role in electrical distribution, common types, installation practices, and safety considerations. An electrical panel, also known as a breaker box or load center, serves as the main distribution point for electrical power within a building. It receives electricity from the utility company and distributes it to various circuits throughout the building. The panel houses circuit breakers, which protect each circuit from overcurrent conditions. Circuit breakers are automatic switches designed to trip and interrupt the flow of electricity when the current exceeds a safe level. This protects the wiring and connected devices from damage due to overloads, short circuits, or ground faults. There are several types of circuit breakers commonly used in electrical panels. Firstly, standard thermal magnetic breakers are the most common type and use a combination of thermal and magnetic mechanisms to trip the circuit. Secondly, ground fault circuit interrupters, or GFCIs, are designed to protect against ground faults, which can occur when electricity leaks to ground. They are commonly used in bathrooms, kitchens, and outdoor areas where there is a risk of electric shock. Thirdly, arc fault circuit interrupters, or RSIs, are designed to protect against arc faults, which can cause fires. They are required in many areas of the home, such as bedrooms and living rooms. Electrical panels come in various sizes and configurations, depending on the electrical load requirements of the building. The size of the panel is determined by the number of circuits it can accommodate and the maximum current it can handle. Panels are typically rated in amps, such as 100 amps, 200 amps, or 400 amps. When installing an electrical panel, it is important to follow the National Electrical Code, or NEC, and local electrical codes. The panel should be installed in a dry, accessible location away from flammable materials. The panel should be properly grounded to provide a safe path for fault current. The wiring inside the panel should be neatly organized and properly labeled. Each circuit breaker should be labeled to indicate the circuit it protects. The labeling should be clear and accurate to facilitate troubleshooting and maintenance. Circuit breakers should be sized appropriately for the circuits they protect. The breaker should be rated to handle the expected load of the circuit without tripping under normal conditions. Overloading a circuit can cause the breaker to trip frequently, which can be a nuisance and a safety hazard. If a circuit breaker trips frequently, it may be necessary to reduce the load on the circuit or install a higher rated breaker. However, it is important to ensure that the wiring is also rated to handle the increased current. Replacing a circuit breaker is a relatively simple task, but it should be done with caution. Firstly, turn off the power to the circuit by switching off the main breaker in the panel. Secondly, remove the cover of the electrical panel. Thirdly, use a voltage tester to verify that the circuit is de-energized. Fourthly, disconnect the wires from the old breaker and remove it from the panel. Fifthly, install the new breaker and connect the wires. Sixthly, replace the cover of the panel and turn on the power. Electrical panels and circuit breakers are essential components of electrical systems, providing protection against overcurrent conditions and ensuring electrical safety. Understanding their function, types, installation practices, and safety considerations is crucial for homeowners and electrical professionals alike. By following the National Electrical Code, or NEC, and local electrical codes, and adhering to safety guidelines, you can ensure that your electrical system is safe and reliable. When selecting circuit breakers for an electrical panel, several factors should be considered to ensure proper protection and compliance with safety standards. These factors include the type of breaker, the current rating, the voltage rating, the interrupting capacity, and a listing by a nationally recognized testing laboratory, or an RTL. Let's discuss each of these factors in detail. Firstly, the type of breaker is an important consideration when selecting circuit breakers. There are several types of breakers available, each designed for specific applications. Standard thermal-magnetic breakers are the most common type and are suitable for general-purpose circuits. Ground-fault circuit interrupters, or GFCIs, are required in areas where there is a risk of electric shock, such as bathrooms and kitchens. Arc-fault circuit interrupters, or RFCIs, are designed to protect against arc faults, which can cause fires. Secondly, the current rating of the breaker should be selected based on the expected load of the circuit. The breaker should be rated to handle the continuous current of the circuit without tripping under normal conditions. The current rating is typically marked on the breaker in amps. It is important to avoid oversizing the breaker, as this can reduce the protection against overloads. Thirdly, the voltage rating of the breaker should match the voltage of the electrical system. In residential applications, breakers are typically rated for 120 volts or 240 volts. In commercial and industrial applications, breakers may be rated for higher voltages such as 480 volts or 600 volts. Fourthly, the interrupting capacity of the breaker is the maximum current that the breaker can safely interrupt without being damaged. The interrupting capacity is typically marked on the breaker in amps. It is important to select a breaker with an interrupting capacity that is sufficient for the potential fault current at the installation location. Fifthly, the listing by a nationally recognized testing laboratory, or NRTL, is an important indication of the safety and reliability of the breaker. NRTLs, such as Underwriters Laboratories, or UL, and Intertech, or ETL, test and certify electrical products to ensure that they meet applicable safety standards. Breakers that are listed by an NRTL have been tested and found to be safe for their intended use. In addition to these factors, it is important to consider the physical size and configuration of the breaker when selecting circuit breakers for an electrical panel. The breaker should be compatible with the panel and should fit properly in the breaker slot. It is also important to ensure that the breaker is properly installed and connected to the circuit wiring. Selecting the right circuit breakers for an electrical panel is essential for ensuring proper protection and compliance with safety standards. By considering the type of breaker, the current rating, the voltage rating, the interrupting capacity, and the listing by a nationally recognized testing laboratory, or NRTL, you can select breakers that are safe, reliable, and appropriate for your application. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations, including requirements for circuit breakers and electrical panels. Compliance with the NEC is essential for ensuring electrical safety and preventing electrical hazards. Let's discuss some of the key NEC requirements related to circuit breakers and electrical panels. Firstly, NEC Section 110.3 covers the examination, identification, installation, and use of equipment. This section requires that electrical equipment be installed and used in accordance with the manufacturer's instructions and that it be listed or labeled by a nationally recognized testing laboratory, or NRTL. Secondly, NEC Section 240 covers overcurrent protection, including requirements for circuit breakers and fuses. This section specifies the types of overcurrent protection devices that are permitted for different applications and the requirements for their installation and sizing. Thirdly, NEC Section 312 covers cabinets, cutout boxes, and meter socket enclosures. This section provides requirements for the installation and construction of electrical panels, including requirements for working space, access, and protection against physical damage. Fourthly, NEC Section 408 covers switchboards, switchgear, and panel boards. This section provides requirements for the installation and construction of electrical panels, including requirements for the arrangement of circuit breakers, the identification of circuits, and the grounding of the panel. Fifthly, NEC Section 409 covers industrial control panels. This section provides requirements for the installation and construction of industrial control panels, including requirements for the protection of control circuits, the identification of components, and the grounding of the panel. In addition to these sections, there are many other NEC requirements that may be relevant to circuit breakers and electrical panels depending on the specific application. It is important to consult the NEC and local electrical codes to ensure that your electrical installation complies with all applicable requirements. Compliance with the National Electrical Code, or NEC, is essential for ensuring electrical safety and preventing electrical hazards. By following the NEC requirements for circuit breakers and electrical panels, you can help to ensure that your electrical system is safe, reliable, and compliant with industry standards. In electrical systems, the interrupting rating of a circuit breaker is a crucial parameter that indicates the maximum fault current the breaker can safely interrupt without failing or causing damage. Understanding the interrupting rating and its significance is essential for ensuring electrical safety and preventing catastrophic failures. Let's delve into the details of the interrupting rating, its determination, and its importance in electrical system design. The interrupting rating, also known as the short circuit interrupting capacity, or SCCR, is the maximum current that a circuit breaker can safely interrupt under fault conditions. It is typically expressed in amps and represents the breaker's ability to clear a short circuit or ground fault without being damaged or causing a fire. The interrupting rating is determined by testing the circuit breaker under simulated fault conditions. During the test, the breaker is subjected to a high current fault, and its ability to interrupt the current and clear the fault is evaluated. The interrupting rating is the highest current the breaker can successfully interrupt without failing. The interrupting rating is an important consideration in electrical system design because it ensures that the circuit breakers can protect the system from overcurrent conditions. If the fault current exceeds the interrupting rating of the breaker may fail to interrupt the current, which can result in equipment damage, fire, or even injury. The interrupting rating of a circuit breaker should be selected based on the available fault current at the installation location. The available fault current is the maximum current that can flow in a circuit under fault conditions. It is determined by the impedance of the power source and the impedance of the circuit. The interrupting rating of the breaker should be equal to or greater than the available fault current. In addition to the interrupting rating, it is also important to consider the voltage rating of the circuit breaker. The voltage rating is the maximum voltage that the breaker can safely interrupt. The voltage rating should be equal to or greater than the system voltage. When selecting circuit breakers, it is important to consult the manufacturer's specifications and the National Electrical Code, or NEC, to ensure that the breakers have the appropriate interrupting rating and voltage rating for the application. The NEC provides guidelines for determining the available fault current and selecting circuit breakers with adequate interrupting ratings. Understanding the interrupting rating of circuit breakers and its significance in electrical system design is crucial for ensuring electrical safety and preventing catastrophic failures. By selecting breakers with appropriate interrupting ratings and voltage ratings, you can help to protect your electrical system from overcurrent conditions and ensure the safety of people and equipment. When working with electrical panels and circuit breakers, safety should always be the top priority. Electrical hazards can cause serious injuries or even death, so it is important to take precautions to protect yourself and others. Let's discuss some important safety tips to follow when working with electrical panels and circuit breakers. Firstly, always turn off the power before working on any electrical equipment. This includes circuit breakers, electrical panels, and wiring. Turn off the main breaker in the panel to de-energize the entire system. Secondly, use a voltage tester to verify that the power is off. Even after turning off the breaker, there may still be voltage present in the circuit. Use a voltage tester to confirm that the circuit is de-energized before touching any wires or components. Thirdly, wear appropriate personal protective equipment, or PPE. This includes safety glasses, rubber gloves, and insulated tools. Safety glasses protect your eyes from flying debris, rubber gloves protect you from electric shock, and insulated tools prevent you from accidentally grounding yourself. Fourthly, never work alone. Always have someone nearby who can assist you in case of an emergency. Fifthly, be aware of your surroundings. Make sure the area is well lit and free of obstacles. Avoid working in wet or damp conditions. Sixthly, follow the manufacturer's instructions. Always read and follow the manufacturer's instructions for installing, repairing, and maintaining electrical equipment. Seventhly, if you are not comfortable working with electricity, call a qualified electrician. Electrical work can be dangerous, so it is best to leave it to the professionals if you are not properly trained. Eighthly, never bypass or disable safety devices. Circuit breakers, ground fault circuit interrupters, or GFCIs, and arc fault circuit interrupters, or FCIs, are designed to protect you from electrical hazards. Never bypass or disable these devices. Ninthly, inspect electrical equipment regularly. Check for damaged wires, loose connections, and other signs of wear and tear. Replace any damaged equipment immediately. Tenthly, keep electrical panels clean and dry. Dust, dirt, and moisture can cause electrical equipment to malfunction. Keep electrical panels clean and dry to prevent electrical hazards. By following these safety tips, you can reduce the risk of electrical hazards and protect yourself and others from injury. Remember, electrical safety should always be the top priority when working with electrical panels and circuit breakers. In conclusion, understanding circuit breakers, electrical panels, and safety practices is paramount for ensuring safe and reliable electrical systems. Whether you are a homeowner or an electrical professional, the knowledge of these components, their functions, and their proper installation and maintenance is essential. Circuit breakers serve as the primary protection against overcurrent conditions, safeguarding wiring and equipment from damage due to overloads, short circuits, and ground faults. They come in various types, including thermal magnetic breakers, ground fault circuit interrupters, or GFCIs, and arc fault circuit interrupters, or FCIs, each designed for specific applications and protection needs. Electrical panels, also known as breaker boxes or load centers, act as the central distribution points for electrical power within a building. They house the circuit breakers, organizing and distributing electricity to different circuits throughout the building. Proper installation, labeling, and maintenance of electrical panels are crucial for efficient and safe operation. When selecting circuit breakers for an electrical panel, several factors must be considered, including the breaker type, current rating, voltage rating, interrupting capacity, and listing by a nationally recognized testing laboratory, or NRTL. Choosing the right circuit breakers ensures adequate protection and compliance with safety standards. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations, including specific requirements for circuit breakers and electrical panels. Adhering to the NEC ensures that electrical systems meet safety standards and operate reliably. The interrupting rating of a circuit breaker is a critical parameter that indicates its ability to safely interrupt fault currents. Selecting breakers with appropriate interrupting ratings is essential for preventing equipment damage and ensuring safety during overcurrent events. Safety practices are paramount when working with electrical panels and circuit breakers. Always de-energize circuits before working on them, use appropriate personal protective equipment, or PPE, and follow manufacturer's instructions. If you are not comfortable working with electricity, it is best to call a qualified electrician. By prioritizing safety and adhering to best practices, you can minimize the risk of electrical hazards and create a safe environment for yourself and others. In summary, circuit breakers and electrical panels are essential components of modern electrical systems. Understanding their functions, selection criteria, installation practices, and safety considerations is crucial for ensuring safe, reliable, and compliant electrical installations. Whether you are a homeowner maintaining your home's electrical system or an electrical professional designing and installing electrical systems, the knowledge of these components and their associated safety practices is invaluable. Remember to always prioritize safety and seek professional assistance when needed.